passing wanted signal and to block unwanted signal. So there are basically three types of filters. First of all, we will see high pass filter. High pass filter allows to pass high frequency while blocks low frequency, and that is why it is called high pass filter. Another type of filter is a low pass filter, and combination of both high pass filter as well as low pass filter, we will get band pass filter. But initially we will see about the high pass filter only. As far as designing part is concerned, then what type of components to be taken is depending on the formula, which is Fc is equal to 1 upon 2 pi Rc, that is the cutoff frequency. Fc is equal to cutoff frequency, which is Fc, and R is the value of resistor which is to be used in the circuit which we will make in case of high pass filter. C is the value of capacitor. So C here formula for the cutoff frequency Fc is equal to 1 by 2 pi Rc Hertz. Or if we want to find resistor, if cutoff frequency is known, value of capacitor is known, then value of resistor can be calculated, and which is R is equal to 1 upon 2 pi Fc into capital C omega or ohm. Or capacitor C is equal to 1 upon 2 pi cutoff frequency into value of resistance R, and unit is farad. So this is about the designing part. What amount of resistor, what amount of capacitor, what value of resistor, what value of capacitor to be taken into consideration for finding cutoff frequency, that we have taken here. So high pass filter plus low pass filter is equal to band pass filter. But initially we will see about the high pass filter only. So this is the circuit. This capacitor is connected in parallel with the resistor in this manner. So this capacitor and this part is a high pass filter. So this part is a frequency generator and another part is a measuring part, that is a voltmeter. So frequency, through this frequency generator is being supplied to this high pass filter section. Then what amount of voltage is coming at the output, and that is to be measured with the help of voltmeter. Initially set voltage here, which may be 5 volt minimum and 12 volt maximum, but keep it 5 volt. Then change the frequency from 100 Hz, 200 Hz, 300 Hz, like this, from lower frequency to higher frequency. Initially, since this is a high pass filter, in case of low frequency, there will be no output or low output at voltmeter shown here in the diagram. So whatever the frequency, we are providing this from frequency generator, and corresponding voltage to be measured with this voltmeter. Whatever the voltage we are getting, and write it in the tabular form. Whatever the frequency corresponding to that, what is the voltage that is to be written into the table in tabular form. See here, if we are providing 100 Hz, the voltage is 0.301. If we are providing 200 Hz, then voltage is 0.302 volt. If we are providing 300 Hz, then voltage is 0.303, and so on. If we are providing frequency 400 Hz, then it is 0.303. For 500 Hz, it is 0.800. For 600, 1.100. For 700, it is 1.5. So this is all about the frequency versus voltage. See here, at the 800 frequency Hertz, voltage is 2.03. At 900 Hertz, voltage is 2.50 volt. Voltage is at a y-axis and frequency at a x-axis. So voltage versus frequency graph is plotted. Now frequency is 1000 Hz and voltage 3.10. For 1100 Hz 3.90. And further, for 1200 Hz voltage 4 volt. For 1300 Hz voltage is 4.10. For 1400 Hz voltage is 4.12. And for 1500 Hz voltage is 4.1. So this is about the high pass filter, and this is a graph plotted. On y-axis there is a voltage and on x-axis there is a frequency. How low frequency in this region? That low frequency is blocked while high frequency is being passed, and that is why it is called high pass filter, because only high frequencies are passing and low frequencies are getting blocked. So this is the graph of a high pass filter. Low frequency blocks here, low frequency block and high frequency pass. So this is about the graph or graphical representation of a high pass filter, which is plotted voltage on y-axis and frequency on x-axis. Now we will say about low pass filter. So you can see resistor is connected here and capacitor is connected here. So resistor is connected in parallel to the capacitor. So this part or this section is low pass filter section or region. As usual, we are providing frequency with the help of frequency generator. So this section is a frequency generator section. Now whatever the frequency we are providing to this circuit, then whatever the voltage we are getting to be measured with the help of voltmeter connected here. That output will be measured with the help of this voltmeter. And further, what are the values coming from the voltmeter? See here, for 100 Hz 4.85, for 200 Hz it is 4.90, for 300 Hz it is 4.89 volt. Again for 400 Hz it is 4.85, 500 Hz 4.90 and 600 it is 4.89. Further, for 700 4.70, for 800 it is 4.65, for 900 it is 4.55 volt, for 1000 Hz it is 2.80, for 1100 Hz 2.75, and for 1200 Hz it is 2.65. Continuously voltage is decreasing. So there is a drop in its voltage as frequency is increasing. Further you can see, for 1300 Hz it is 1.80, for 1400 Hz it is 1.05, for 1500 Hz it is 1 volt. Continuously. As frequency is increasing, voltage is decreasing. See, for 1600 Hz it is 0.90, for 1700 Hz it is 0.85, for 1800 Hz value is 0.84 volt. You can observe from the graph. low frequency is being passed and high frequency is blocked. You can observe in this graph. Voltage versus frequency graph is plotted. Low frequency is passed while high frequency is blocked, and that is why it is called low pass filter. A filter which filters, a filter which will not allow high frequency are called low pass filter, which will allow only low frequencies, and we will get output. Now combination of both, that is band pass filter. There are two filters, high pass filter as well as low pass filter, connected in this manner. This filter is connected with this filter, and finally, as usual, we are getting voltage from this voltmeter. Now, this is a high pass filter and there is a low pass filter. So, high pass filter plus low pass filter, which is equal to band pass filter. Now, this band pass filter circuit is ready. We have to provide frequency from this frequency generated to this band pass circuit. Whole of this is a band pass circuit. Now we apply one by one from low to high from this frequency generator and measure the voltage with the help of this voltmeter. So we will get this result of the band pass filter on the voltmeter connected here. So whatever the corresponding frequency applied or frequency provided, correspondingly voltage will be measured, noted with this voltmeter. So graph of a band pass filter is like this. So low frequency will not pass, high frequency will not pass, only this band will pass. And that's why this is called band pass filter. So this is all about the high pass filter, low pass filter, and finally band pass filter. So basic is that to block unwanted signal and to pass wanted signal, and that is why it is called filter. So there are types as per the requirements which filter we require, whether high pass filter, low pass filter, or band pass filter. So this is all about the filters which we have seen.